Karibuni sana. Today we dive into one of the most practical and exam-relevant topics in mathematics, probability. We walk through a question using a tree diagram, real-life logic, and visual clarity. Whether you are in my home area, Mwea, or whether you are in Nairobi City, the capital of Kenya, or anywhere else across Kenya and all over the world, this is for you. Let's understand the odds step by step. The question was question 19 in the KCSE of 1995. The probabilities that a husband and wife will be alive 25 years from now are 0.7 and 0.9 respectively. Find the probability that in 25 years' time, A, both will be alive, B, neither will be alive, C, one will be alive, and D, at least one will be alive. All right, let's carefully walk through the question step by step. We are told the probability the husband is alive in 25 years is equal to 0.7, and the probability the wife is alive in 25 years is equal to 0.9. Then, the probability the husband will not be alive is equal to 1 minus 0.7, which is 0.3, and the probability the wife will not be alive will be 1 minus 0.9, which is equal to 0.1. We assume these are independent events. Part A. Let's calculate the probability that both will be alive. Here, we multiply the probabilities because the two events are independent. So, P, husband alive and wife alive, will be 0.7 times 0.9, which is equal to 0.63. Or, mathematically, when you are working, you just say P both alive is equal to PH, which means the probability of husband, times PW, the probability of the wife, and it is going to be 0.7 times 0.9, which is 0.6. The answer is 0.63. B, probability that neither will be alive. Probability husband not alive and wife not alive is equal to 0.3 times 0.1, which is 0.03, because these events are independent. Or, in symbols, you can say P neither alive, P probability of husband not alive times probability of wife not alive is equal to 0.3 times 0.1, which is equal to 0.03. And the answer is 0.03. At the end of this answer, I'll explain this more. Probability one will be alive. This can happen in two ways. That is, husband alive and wife not alive, which will give you 0.7 times 0.1, which is 0.070. Or husband not alive, wife alive, which is going to be 0.3 times 0.9, which is 0.270. So, P exactly one alive will be equal to the sum, 0.07 plus 0.27, which is equal to 0.34. So the answer is 0.34. This means either husband alive, wife not. So in probability, you say PH times P not wife is equal to 0.7 times 0.1, which is equal to 0.07. Wife alive, husband not, P probability of wife times probability of husband not, and it will be 0.9 times 0.3, which is 0.27. So P1 alive is equal to 0.07 plus 0.27, which is 0.34. So I'm giving this to show you how you work in mathematics. D, at least one will be alive. This is the complement of neither alive. That is, P at least one alive is equal to 1 minus P neither alive, which is equal to 1 minus 0.03, which is going to give us 0.97. Because the probability of neither alive is 0.03, as we have found, and therefore we get the answer 0.97. And therefore the final answers will be for A 0.63, for B 0.03, for C 0.34, and for D 0.97. The question could also have been answered using a tree diagram. So here we have the tree diagram for husband and wife survival probabilities for 25 years. And this tree diagram, I will say this, it branches from the husband's outcome. We start with the husband, that is alive or not alive. Then from each of those branches, we have the wife's outcome, alive or not alive. Each final branch shows the combined probabilities. Both alive implies 0.63, one alive implies 0.07 plus 0.27, which is 0.34, and neither alive will give you 0.03. And that one is very, very clear from the tree diagram. You can see where we are starting. We are starting with H, or husband alive, 0.7, husband not alive, 0.3. All right? Wife, 0.9, not alive, 0.1. That is if the husband was alive. All right? Now, if the husband was not alive and the wife is alive, is 0.9. Wife not alive, 0.1. And therefore, when you combine the probabilities from the top, you have both alive 0.63. That is, you multiply husband alive, wife not 0.7. You multiply 0.7 by 0.1. And then husband not alive, wife alive, 0.3 times 0.9 is 0.27. And finally, neither alive will be 0.3 times 0.1, which is 0.03. So, for the sake of my audience, I have written what I was trying to explain in that tree diagram. So, we will branch on the husband's outcome first, then the wife's outcome comes next. So, in step 1, you have the husband's probability. And the husband alive is 0.7, and husband not alive is 0.3. Step 2, now, you branch now from the two possibilities of the husband. That is, if the husband is alive, 0.7, and the wife alive, 0.9, wife not alive, 0.1, and then the other branch will be, if husband not alive, 0.3, wife alive will be 0.9, and wife not alive, 0.1. So in step 3, you are going to multiply along the branches. That is, for the husband alive, you have 0.7, and for wife alive is 0.9. When you multiply them, you get 0.63. For the husband alive and the wife not alive, you multiply the two, 0.7 times 0.1, you get 0.07. Husband not alive, wife alive, 0.3 times 0.9, which is 0.27. And husband not alive, 0.3, wife not alive, 0.1, multiplied gets 0.03. So, finally, step 4, you read answers from the tree. Both alive, the answer is 0.63. Neither alive, the answer is 0.03. One alive, exactly one, 0.07 plus 0.27, which is equal to 0.34. And finally, at least one alive is 1 minus 0.03, where 0.03 is neither alive, and it is going to give you 0.97, because the maximum probability is 1. Final results from the diagram: A 0.63, B 0.03, C 0.34, D 0.97. And in summary of the tree diagram, H, husband, is at the root, and it branches into alive 0.7 and not alive 0.3. From each of those, it branches into W wife with her respective probabilities. Wife alive 0.9, not alive 0.1. Each final outcome is clearly labeled. Therefore, both alive 0.63, one alive 0.07 plus 0.24, which is 0.34, and neither alive 0.03. pH times PW and pH prime times PW prime. What do these symbols mean? pH is equal to probability that the husband is alive. PW is equal to probability that the wife is alive. pH prime equals probability that the husband is not alive. PW prime is equal to probability that the wife is not alive. The apostrophe means not. So H prime, that's the way is when the apostrophe is put there, is learned, is the opposite of H. So what does pH times PW represent? This is the probability that both the husband and wife are alive. You multiply the two probabilities because these are independent events. One doesn't affect the other. You want the chance that both things happen. Example, if pH is equal to 0.7, that is 70% chance husband is alive, and PW is equal to 0.9, which is 90% chance wife is alive, then pH times PW is equal to 0.7 times 0.9, which is 0.63. So there is a 63% chance that both will be alive after 25 years. Okay, now, what does pH prime and PW prime represent? This is the probability that neither the husband nor the wife is alive. You multiply the chances that each one is not alive. So pH prime equals 1 minus 0.7, which is 0.3, because the maximum probability is 1. And since we know to be alive, the person has a probability of 0.7, we subtract. And similarly, we do the same to the wife, which is 1 minus 0.9, which is equal to 0.1. Then P prime times P W, PH prime times PW prime is equal to 0.3 times 0.1, which is 0.03. So there is a 3% chance that both are gone after 25 years. They will be dead. Why multiply? Why do you multiply independent events? In probability, when you want two independent things to happen together, you multiply their probabilities. Here, you think of it like flipping two coins. The chance of heads on one coin is 0.5, and the chance of heads on both is therefore 0.5 times 0.5, which is 0.25. Same logic applies here in this question of lifespan. Real life analogy. Imagine you are planting two trees. One has 70% chance of surviving. The other has a 90% chance. To find the chance that both trees survive, you multiply 0.7 times 0.9, which is equal to 0.63. To find the chance that both trees die, you multiply 0.3 times 0.1, which gives you 0.03. How to interpret multiplication in probability? Multiplication. Although untouched, I told you I'll come to details at the end of what I've done. Symbols meaning. PH means probability the husband is alive. PW means probability the wife is alive. PH prime means probability the husband is not alive. And PW prime means probability the wife is not alive. The prime, that is apostrophe, means not, or the complement event. So now, this is the theory we are doing. We now also repeat again, why do we multiply? When events are independent, the probability of them happening together is found by multiplying. That is the reasoning. So PH and W is equal to PH times PW. Example in class. If PH is 0.7 and P is equal to 0.9, then both alive is 0.7 times 0.9, which is 0.63. This is because the outcome for one does not affect the outcome for the other. That is, they are independent. Let's take a teaching analogy. You can say multiplication in probability is like combining chances from two independent paths. If you roll a die, whose face has a chance of 1/6, and toss a coin where you have a chance of 1/2 on either head or tail, the chance of rolling a 6 and getting heads is equal to 1/6 times 1/2, which is equal to 1/12. The same applies here. Husband survival is one path, wives is another. To get both, we multiply. So in teaching, PH times PW is equal to probability that both H and W are alive. And the PH prime times PW prime, probability that neither H nor W is alive. As you have seen, or finally, as you have seen, probability isn't just numbers. It's about choices, outcomes, and understanding life uncertainties. I hope this video helped you visualize and simplify the concept. Special thanks to Microsoft Copilot and ChatGPT for powering this journey, and to my PowerPoint slides for bringing the maths to life. Keep learning, keep questioning, and keep growing. Let's use challenges to learn deeply. Good night, and see you in my next question.